The broadcast is now starting. All attendees are in listen-only mode.
We're just going to give a couple seconds for people to jump on. All right, well, hello everyone. Thank you so much for joining our KGP Co. Spring Webinar Series. I do have a few quick announcements before we get started. All lines are muted to avoid any background noise, but there is a questions field on your control panel where you can type in your questions, and I do encourage you to do so throughout the presentation, and we'll definitely try to get to those at the end. Also, this session is being recorded, and the recording will be up on our Spring Webinar landing page this afternoon for viewing. And then lastly, if you do attend 3 or more webinars in our Spring Webinar Series, we will be reaching out to you for your address to receive a free relaxation kit, and those will be shipping when the series ends here at the end of April. So, like I said, thank you so much for joining and welcome to our Spring Webinar Series. Today we are super excited to be featuring AFL, and the name of their presentation is High Density Meets Faster Installation. Our presenter this afternoon is Will Miller. He's the Global Product Lead at AFL. And so with that, Will, take it away and thank you so much.
All right, Piper, thank you. And thanks to KGP for hosting this event. So today I'll be going over what we're calling high density meets faster installation. So what does that mean? So AFL, you may be familiar with some of our products. If you're not, I'll kind of go through a brief overview. But first, a little bit about me and understand who the heck is presenting this. So as Piper mentioned, my name is Will Miller. I'm the global product lead for our outside plant connectivity products at AFL. Been with AFL for about 7 years as a product manager in our cable and connectivity business units in various roles. Have over 13 years experience in fiber optics. That's everywhere from field engineering, that's doing the testing, splicing, troubleshooting, and then just went into engineering and then product management. I'm from South Carolina, just right down the road here from AFL's headquarters here in Duncan. Have a Bachelor of Science degree in Mechanical Engineering from Clemson University. A little bit about me, it's summertime, so about time to crank up the grill. Like weightlifting, watching the Clemson Tigers, Atlanta Falcons football, and the Atlanta United football, so the soccer. Also a huge Disney geek. So a little bit about me, give you some insight as I get into this. So brief outline, what are we talking about here again today? So I wanted to get in first into some evolutions in technology with both fiber and cable. And then really the bulk of what we want to talk about is really some evolutions in closure technology. So how can we harmonize the development coming from the cable side? And you've seen a lot of this. We're talking really high fiber counts and really dense cables. And how do we harmonize that with smaller splice closures, more dense splice closures to take advantage of these high density type technologies? So that's all in what we're going to be going over. First off, just a brief history of AFL and who we are as a company if you're not familiar. First, AFL is a wholly owned subsidiary of Fujikura based out of Japan. If you're not familiar with Fujikura, every time I do a presentation or mention Fujikura, you have half the room ask about fusion splicers and the other half of the room asks about golf shafts. Yes, that's the same Fujikura. They just have they're in a lot of different types of industry. So it's about a $7 billion company and about 57,000 employees. Really 3 big main operating units is telecom and power, where AFL sits, as well as automotive and other electronics. And yes, the golf shafts are in there as well. But they're a bit smaller operation for Fujikura. For AFL, so as I mentioned, we're the wholly owned subsidiary, stands for American Fujikura Limited. We're primarily based in North America, but do have operations in the EU and a little bit in APAC as well. We actually have some operations in Australia, and then across Asia as well. We have 11 global manufacturing locations, so that's everything from conductor accessories, cable, connectivity, terminations, all those sort of things. Really an end-to-end type solution. So what types of products do we sell? Again, it's really everything end-to-end. And what I mean by that is when you call it a fiber to the home network, you have your OLT and your ONT. AFL services everything in between. And that's inclusive of the fusion splicers that are used to splice the fiber together, as well as the test equipment used at the end to test it all. So we're really unique in that regard, that we really do have an end-to-end solution for all those different types of products. We also have a services business. They're kind of located all over, including Europe as well as North America, both the service provider and the enterprise markets. So we do everything from full EF&I work, customer premise install, engineering and design, practically everything you can think of in a services type organization. So why AFL? So very high termination capability. That's really where I sit as part of my the business that I service. The fiber termination space. We do over 44 million fiber terminations a year around the world. Again, that's globally, APAC, Europe, and then as well as our primary manufacturing locations in North America, Monterrey, Mexico, and then in Kent, Washington. So globally, this gives you a good idea of the footprint where we have manufacturing locations. I mentioned in the U.S. In the U.S., here in Duncan, South Carolina, we have, I'm kind of losing track of how many buildings we have. It's around the five or so plants. Then I mentioned Kent, Washington. Our test equipment is located up near Boston, and then we have the termination capability and assembly down in Monterrey, Mexico, in the connectivity organization. And then again, I mentioned UK, Germany, where they do some of the more specialty type products, ADSS and OPGW type products, and then some more operations in Asia as well. All right, so that's a brief introduction on AFL and who we are. So now to get into the meat of this. So what are we seeing today? So, you may have seen a lot of this, and it's kind of repeated ad nauseum, but in the recent events with the COVID situation in 2020, it rings even more true. So bandwidth demand continues to grow. We're seeing internet traffic growing at over a 20% CAGR year over year, and the need is the same as what we've all heard. So it's high-speed needs for gaming, for streaming video, and then last year, as we saw, the need shifted more from consumption to what we're doing today. With the online video chat, working from home, as well as the teaching from home. With this brought opportunity. So you don't want to put anything that happened with COVID in a positive light. It was a lot of negatives, obviously, that went with it. But as an industry, we saw a need to accelerate some change. So that with that, with all the demand, you started to see deployments increase quite a bit. So as I mentioned, there's several catalysts, a lot of them last year. One of them, though, that's been, kind of a slow burn, has been 5G and those mobile low latency applications that coincide with them. So, as of right now, when you're seeing 5G, it's really just a lot of folks and a lot of the service providers that are really promoting 5G. It's all about low latency and high download speeds. Well, the ancillary use cases aren't even here yet, but they're being developed. So autonomous vehicles, that's something that I really get jazzed up about. I love talking about, but you're talking about level 5 autonomy, no completely hands-off driving, robo-taxis, that sort of thing. That's coming down the road and will be enabled by 5G technologies. And then again, last year, so the term, you may have heard it before in other webinars and discussions, so it's closing the digital divide. Rural America, we talk about a lot of the fiber to the home deployments that have been occurring over the past, call it 15 years or so. They've addressed rural America in some cases, but it's been primarily in more metro areas. Because, honestly, when you're looking at where you're getting your best return on invested capital, it's going to be in the metro areas with tighter, higher urban density. But in the COVID-19, we saw, okay, so what about the folks in the rural areas that need to work from home, that need that, needs the teaching, the school over the internet? You know, a lot of them were relying on dial-up. You had folks that were going to Starbucks or McDonald's to get their school or get their kids' school done. So there was just a huge divide in the digital technologies that needed to be addressed and are continuing to be addressed now. Fortunately, there's a lot of help on the way in terms of different federal and state economic stimulus. So last year we saw the beginnings of RDOF and the RDOF bid process. So in October, the FCC awarded $9.2 billion of that $16 billion of that RDOF funds to deploy more services to the rural areas. We saw a lot of that going towards fiber infrastructure. We saw some other stuff, fixed wireless, satellites, some things like that got addressed with RDOF, but a lot of fiber to the home as well. And then some more stuff that's down the road. You've heard a couple different things. There's some folks in Congress today putting forth a new bill, this Accessible Affordable Internet for All Act. That's actually being led by a representative from South Carolina, Rep. Clyburn. And then, you've got Biden's administration, the Biden administration infrastructure package there as well, where they're talking about $100 billion worth of funding to address rural broadband internet. So a lot of things in the works here to grow the deployment. And we're seeing service providers, they're spending about $1.5 billion on fiber cable per year, and that's growing about 3% CAGR, and that's really the traditional service providers. So when we look at municipalities, energy co-ops, alternative providers, that growth is even higher. So you see that's a very large spend on fiber cable. So that's really just to get in there, there's a lot of fiber out there, and a lot of technicians that ultimately are needed to place the fiber and splice it. So that's where we really want to get into how can we accelerate that deployment. And not even just speed, it's all about how do we make room for all this fiber. So in brownfield builds, you're seeing some adjacent technology being used to try to leverage what's already in the ground, what's already in the air. So XWDM technologies, we're seeing that quite a bit as the service providers are starting to deploy 5G. We're starting to see, they call it coexistence elements and things like that, to basically put more bandwidth over top of the same fiber that's already there. So just pumping in additional wavelengths to support the 5G builds. And then as well as some of the higher bandwidth technologies beyond GPON. So XGS-PON, NG-PON 2, those can all be put over the same fiber infrastructure, just utilizing XWDM technologies. Some service providers aren't super familiar with WDM technology, so this introduces some complexity because you think you've got all this fiber and your engineering that goes in with maintaining a network. Now you're pumping multiple bandwidth or multiple wavelengths over the same fiber, so it has some complexity. Also has some added cost. So it's these service providers are really having to figure out what makes the most sense for their network. Now, network planners are starting to be forward-thinking with their fiber runs. So as we're starting to see metro rings, new metro rings being plotted out, where traditionally we may be looking at max of 288, 432 count, maybe even 864. Even 864 isn't enough. I worked on a project years back for a 1728 fiber cable, and it was one customer that was deploying it. And we kind of laughed and said, whoever's going to need 1728. Now it's relatively common. You're seeing a lot of the service providers deploying it. You're seeing a lot of municipalities deploying 1728. And now we're getting into even more ridiculous fiber counts, 3456, 6912, very high fiber counts that are being deployed in different applications. Some of them are more focused towards the data center side, but we're seeing these again getting deployed in some of the metro areas and some of these fiber rings. So again, planning for future rather than putting in a low amount of fiber initially and then trying to retrofit with WDM or things like that. So the pictures on the screen here show some examples of the complexities that go in with adding more fiber to already congested networks. So, these are some kind of worst cases, but, some of them are relatively common, especially in the underground space. Hopefully they're not too common in the aerial space like you see in that one picture, but, that's pretty ugly as you're attaching more and more drops, especially on joint use poles when you've got, you've got your RBOX there, you've got competitive exchange carriers. Now you're starting to add energy co-ops. There's a lot of utility, there's a lot of business going on in the pole a lot of different competing fiber networks that we have to worry about and address it and make it look nice and manageable and maintainable over the the life of the network. Eventually some of these things may get cut, they may fall down, so you want to make sure they're maintained appropriately so you can go and service them later. And then you can see the underground too. So these handholds, a lot of folks are putting in these giant manholes or giant handholds in the vaults to maintain these large count cables. So how can we potentially shrink all that down? Or if there's already space in place, how can we take advantage of the space that's already there? So this is where we get into the cable density evolution. So I hope a lot of folks on the call today have seen some of these technologies. If not, I'll hit them briefly so you can get an idea of what some of the technologies look like today. And they're both focused towards the same objective, but with different capabilities and different methods of getting there. So on the really high density, when I say really high density, I mentioned 6,912 fibers. That's more towards the ribbon technologies, obviously. So hopefully you're not doing that many single splices. But so AFL, we've released in the past few years our wrapping tube cable with spider web ribbon. Essentially what it is, if you're not familiar with ribbon technology, essentially the ribbon technology is 12 fibers laid in a encapsulated ribbon, encapsulated structure, where they lay into the cable in a stacked organization. And then you actually use a mass fusion splicer to splice 12 fibers at one time. This is great, but when you put them into a cable, those rigid straight ribbons, when you stack them and make a round cable, there's a lot of interstitial areas that are covered with either a filling compound, a gel, or maybe a foam or some type of water block material. But there's a lot of empty space in that cable. So AFL, we have worked with our parent company Fujikura and developed what we call spider web ribbon. So what this does is, rather than encapsulating all 12 of those fibers in a rigid structure, those fibers are each individually bonded to the adjacent fiber. So in a structure, they're all still tied together as one combined 12 fiber unit, but they are able to collapse and roll up on each other like you see in the slide here and become a tightly defined unit. What that allows us to do is then strand those together and combine them into individual binders or bundle sizes, bundle units. And those bundle units are then stranded and put into a overall cable structure. And what this does, since those fibers do collapse down rather than maintaining a rigid, straight organization, that collapsible structure allows us to fill all the interstitial spaces inside of a ribbon cable. So what that means, we cut out all those interstitials. A equivalent 432, for instance, fiber cable to a 432 fiber rigid ribbon structure has reduced the diameter significantly. We've seen in cases, and when you do a comparative, it's cases up to 50%, just depending on the fiber count. And with that comes a lot of advantages. You can think smaller duct sizes, more cable on a reel, potentially lighter reels. You get more cable on a reel, that means more reels per truck, so it lowers your freight costs. So you can kind of get an example of how a smaller diameter cable, it's just not easier to bend and easier to work with. There's a lot of advantages down the road by going to a smaller cable structure. Going to maybe a little bit lower fiber count, even though 432 is relatively large to where we were many years ago, to the OSP microcore. So you may have heard micro cables, global cables, jettable cables, a lot of different vernaculars used for this type of cable. So OSP microcore is AFL's approach to a micro jettable cable. Again, up to 432 fibers, and we have several different varieties. So we've gone from just our standard, what we call our LM series, which is a 250 micron structure, very thin wall jacket that actually has some ridges on the outside of the jacket, or not really ridges, but striations that essentially capture that airflow, that laminar airflow, and help it guide it and blow it through the microducts. So really the intent is to shrink these cables down and allow you to pump more fiber into a smaller footprint. So again, network planning, trying to plan for future growth. You can either pump a lot of fiber in there using something like a wrapping tube cable with spider web ribbon, or utilize what you see in the picture there, an example of a multi-path microduct where you may have 7 pathways around, each one of those 13 millimeters in diameter. and blow in one cable. Then you need to expand it, blow in another, blow in another. And you can see how you can really expand your fiber count, expand your capability, and also defer your costs. So you have the pathway in place, and if you use a standard 2-inch conduit, as in the picture example there, you push or pull in a 432 fiber in a conventional 2-inch interduct. Utilizing one of these multi 7-way microducts, you can get up to 2,000 fibers in there, and just do 288 fibers at a time. You build it as you grow. And we have some other varieties out there as well. LMHD was an extension of the LM series microcore. We went to a thicker jacket with some additional air mid strength members in there. We basically treat it just like a standard loose tube cable. So it's up to a 600-pound pull rating, just like most conventional outside plant cables today, and also has a thicker jacket that allows you to lash it aerially. So it's really a do-it-all type of cable. You still get the advantage in the LMHD of being the smaller diameter. So you think of override situations. Again, make some room. So how do I put a conventional type cable, if I had, I'll take that example, that 432 and that 2-inch duct, that's the only pathway I have. So if I use a conventional 144, I'm likely having to bore and put in a new pipe, 1 inch, 1 1/4, whatever it may be for that size cable. Where if going with an LMHD, you can potentially override or do an overpull situation where you could rod in a pull string and pull an LMHD cable because of its smaller diameter size. We achieve that by packing the tubes more dense and having smaller buffer tubes, just an overall smaller packing structure. And then lastly, we have the LM200 series, which essentially takes a very similar style design, but again, shrinks everything down. Because now we're going to shift from a 250 micron fiber, same 125 micron glass, but a smaller 200 micron coating versus the legacy 250. Splicing is all the same. It uses the same fusion splicers because it's all the same 125 glass, just with advantages in or advances in coating technologies. They've been able to shrink the 200 micron fiber down. So now you can imagine you get the fiber size down, allows you to get smaller buffer tubes again. Smaller overall cable, so that really accelerates how much you can put into a duct. So taking the example of that 13 millimeter duct where we were putting in 288 fibers, you're actually able to then bump it up to 432 fibers for each one of those pathways. So it really gives you a lot of advantage there. All right, so how do we couple all these high density cables and use a smaller handhold? Things like that, small, less space on the pole, less space on the strand. We're all still using conventional splice closures that were all developed years ago, not really designed for these high density cable structures. So AFL being the pioneer for a lot of these high density cable technologies, we said, okay, now it's time to develop a splice closure that marries up well with those cable technologies. So AFL developed and launched last year our Apex fiber optic splice closure line. So going quickly into Apex, what were the advantages that we really wanted to approach? So again, spiderweb ribbon has that collapsible design. So if you're, somebody's on the call here and is used to splicing standard ribbon cable, typically, unless you have a very deep splice tray, you don't put any splice or any slack inside of the splice tray. It's all direct into the tray. You kind of see that in the picture there at the bottom right. Typically comes straight into the tray and straight into the holder, and you store all the slack down in the basket. This works okay for some cases, but having to adjust the slack back and forth can be kind of aggravating. A lot of splicers, you like to have slack in the tray for reworks or whatever it may be. You can't have any crossovers inside of your splice tray when you're doing flat matrix ribbon, just because of the rigid structure that it's in. You cross those two ribbons over and try to slack it out. It just builds up really big, and it's going to start bulking out and not fitting inside of the splice tray essentially. The advantage to spiderweb ribbon is you can essentially treat the slack just like a loose buffered fiber. And that's the picture you see there in the top right. That is the spiderweb ribbon. 576 spiderweb ribbon fibers. So all of those are then laid in that tray, and we have a full 2 loops of slack in that picture. So we're cramming 576 SWR fibers in one tray, where previously we're putting 144 in that other tray. And I will argue in that one tray, you could probably go to a 288, but that's the max. You know, it's really the limit. And again, you're not storing any slack in that tray. Another advantage is the slack basket capability. So storage in slack basket, it doesn't require any transition tubes or spiral wrap or anything like that, because it all lays in there and collapses down. You can actually see we did a mid-span there. It's around 10 to 12 feet. I can't recall the exact number. It's 10 to 12 feet, pretty typical for a mid-span application, is inside of that splice basket. And that's actually in our Apex X2, which I'll talk about the sizes here shortly. So with a splice closure that takes advantage of the mass fusion and the high density capability, you can essentially treat all of your slack storage just like a loose buffer, but get all the same advantages that you get out of mass fusion by doing the 12 fusion splices at one time. So talking about splice density, so what really does it mean? So again, we want to take everything, we want to shrink it down. So when you look at higher fiber count closures that are out there to maintain or manage some of these fiber counts, they're fairly large. They can be anywhere from 30 to 36 inches long, and fairly large in diameter. And what we've done with the Apex fiber optic splice closure is we shrank it down to a 10-inch diameter, and the Apex X2 is a 25-inch long dome. So single fusion, we support up to 432. Standard mass fusion up to 864. Now the real advantage again comes into when we start looking at collapsible fiber types like AFL's spiderweb ribbon. So a lot of this, the spiderweb ribbon, or a lot of the fiber technologies I mentioned, 200 micron fiber. 200 micron fiber is coming. It's here. It's going to be pretty much the de facto standard at some point in the not too distant future. And we've started to implement it in SWR cable types. So I talked about the LM200. We're starting to implement it into our wrapping tube cable. So if you're utilizing your wrapping tube cable with a 3,456 fiber and 200 micron, you can do that many fusion splices inside of the X2, a 25-inch long dome. If you're using our standard 250 micron fiber, that'll limit you to 1728. But still, again, in a 25-inch long dome footprint, well exceeds anything that really you see out there in the industry prior to the Apex launch. And now with the X2S, what we did is we essentially took the same internals, the same base and ceiling and all that, and we just came up with shorter internals. So we want to start putting lower fiber counts. When I say low, that's relatively low. Smaller fiber counts in the X2, at least, in the smaller form factor bolts or handholds. Then we go with the X2S, it's only a 20-inch long, and then we essentially have our capacity. So it's half the size splice trays. So you're at 216 fibers, single fusion, 432 mass fusion, and then going to the collapsible fiber types like AFL spiderweb ribbon, it's 1728 using 200 micron fiber or 864 using 250 micron fiber. So what do you get when you marry these together? So, okay, great. You got an ultra dense cable, you've got an ultra dense closure. What does it gain me? All the stuff's getting so small. I make fun of some of the smartphone manufacturers. They keep getting the phones thinner and thinner. They're thin enough now, in my opinion. What's the advantage of getting thinner and thinner, smaller and smaller? There's actually a synergy with wrapping tube cable, for instance. So we took one example here. In the pictures we show. So look at a competitor's 864 fiber ribbon cable, conventional style ribbon cable that we've been using for years and years. You typically pull that in a 1 1/4 inch duct with some of the designs we've seen. There's some are actually larger, but more of the leaders we've seen are 1 1/4 inch capable, around an inch in diameter for the cable itself. But the bend radius typically, plus the closure, typically requires you to put in a 30 by 60 inch handhole. So what happens if we shrank everything down? We wanted to use the same 864 fibers, but can I put it in a smaller handhole when I couple that with the Apex splice closure? And the answer is yes. So in this example, utilizing AFL wrapping tube cable, 864, again, and if you recall the previous slide, you can go up to 864 fibers, 250 micron inside of the Apex X2S. So utilizing the Apex X2S, you can go from a 30 by 60 to a 24 by 36. Also reduces the depth of the handhole. So if you're familiar with construction costs, you're paying a cost for how much you have to dig to put the handhole in. Typically, they're digging almost twice as deep as the handhole depth. So your cost for actual installation is exorbitant the deeper that you go. Same thing on your installation cost for your cable. So again, if the pathway is not in place and you're calling out a bore rig and do some horizontal drilling, you got to put in a new duct. Your costs go down as duct size goes down, obviously. So you're displacing less material. It's easier to do. So with the the AFL wrapping tube cable, that 864 ribbon cable is now capable of going into a 1-inch interduct rather than that 1 1/4 inch interduct. So it lowers your cost there. So we really quantified some of this. So for instance, the handhole in our research that we've done can lower your material costs. So in this example here, going from the 30 by 60 to the 24 by 36, and this all depends on the vendor, but it can go anywhere up to $400 difference per handhole. And then look at the installation expense. Again, you're not digging as big of a hole. So you're between $100 and $200 savings just from an installation perspective per handhole. So when you're decreasing your handhole cost that much in a greenfield build, you can really see the advantage going, in fact, this cable technology or legacy cable technology now to the AFL wrapping tube cable technology and the Apex splice closure technology. Also with smaller handholes, this gives you more options in network design. If you're wanting to cram, and I say cram lovingly, you don't want to actually cram fiber cables, obviously, but you can put more cable and this closure into an already congested handhole. So we're taking up less of a footprint where we had to get a whole 30 by 60 to put this into. Imagine when you start adding more stuff into that, it starts to get really busy really fast. Well, if you had a pre-existing 30 by 60 handhole and you already had a competitor 864 ribbon cable and an opposite, other type of splice closure in there, we can take our solution and just put it right there on top. So, it's not just greenfield builds, it's going with the brownfield as well. Also enhances your space savings on poles and messengers. The whole value prop on messengers, the bigger the closure, as you start to get a bigger closure, the closure itself may not weigh all that much, but when you start to get an inch or more of radial ice around that closure can get pretty heavy pretty quick. So you're starting to talk about additional loading on messengers that you got to be concerned with. Saving space on poles for some of the utilities are starting to pole mount closures. Having smaller closures on the poles is advantageous for folks that still climb the poles. Less surface really to work around when you're talking a length as it scales up the pole. And I mentioned a little bit about the smaller size of wrapping tube cable and advantages there. The freight costs, wider cable means more on reel, less trucks. A smaller closure means more on a pallet, again, less trucks. So again, there's kind of a building value prop, snowballing value prop as you add all this stuff together. Another feature that, this is my main feature that I really enjoy the Apex Splice closure is really the fast cable installation. So you look at other cable or cable splice closures out there, they use a variety of different fasteners and cranks and things like that to install the cable. Like some of them better than others. We've been in the industry for quite a while and have some legacy solutions that had a lot of screws, and we want to get away from that. You also have the O-ring. So the O-ring in the splice closure is really a very important piece of the closure. So overall, from a cable installation perspective, what is the splice closure doing? And that's protecting the fiber splices, really, right? So it's protecting the fiber splices in the outside plant environment from the elements in the outside plant. That's everything from the weathering to impacts and extrinsic forces from things falling on it and things like that, insects, squirrels, you name it. So the big thing that we see a lot of failures come from is the sealing. So if the closure doesn't really seal properly, then you got water buildup that can turn into ice that can attenuate fibers. So sealing was priority one when we went through the development of that Apex splice closure. So the sealing systems, they protect up to 20 feet of water ingress per the Telfordia GR 771 standard. And then in the picture there, we've actually integrated the dome to base seal. So there's really two sealing elements. The dome to the base, so as you attach the dome to the base, you've got to seal that interface. And that's typically done with an O-ring. And most of the times with that O-ring, you've got to take that O-ring off, discard it somewhere. Typically, I see folks, they'll take the O-ring and they'll put it in the dome and they'll kind of set the dome over to the side. I've gone into many splice closures myself, and I've seen maybe some of the people on this call, I've seen some of your videos on LinkedIn where you open up a splice closure on video and then water just dumps out of it. And a lot of the ones that I've seen do that don't have the O-ring installed. So, you know, a lot of the fusion splicers, I've met a lot of you guys and you're very proud of your work. Most fusion splicers I've met, they take pictures of the final quality audit of the closure. Well, then what happens down the road when somebody else goes to maintain that network? It destroys all that hard work. They forget to put the O-ring on. And then you get water ingress issues, again, the freezing and everything else. So now with the O-ring, you don't have to remove it in the field. It is retained to the dome with a thin plastic substrate. So we take a rigid plastic ring, and then we put that into a mold, and then we overmold the rubber that's the O-ring is constructed from. And then we screw that into the dome, and it remains there. So you take the dome off, and it looks just like you see in the picture there. It stays retained and in place. Get the question, what happens when it messes up? Because at some point it will get damaged. You'll drop a wrench on it, I don't know. You'll accidentally, instead of putting it dome side first, you'll flip it upside down and put the O-ring towards the ground, and it'll hit a rock or something and get torn. If it gets damaged, you want to replace it, and you can't. So you simply just back those screws out, replace the O-ring, and then go about your business as usual. So we have all those maintenance items all set up and available to maintain the closure. All right, this is my favorite part, is the second piece of sealing. So you seal the dome to the base. Now you got to seal the cable. So how do you seal the cable and not have to worry about grommets or tapes or glues or all this stuff that's a pain? So what we've done is the AFL Apex closure utilizes a gel wedge sealing technology. So we have 6 individual gel sealing wedges that remove from the cables or from the closure independently and rotate out of place. So it rotates and removes completely toolless. And you'll see in the video there that latch depresses, and I'll play it again. So there's a white latch that you depress by hand. There's a lock on that, so you push and then pull. It's almost like push and turn, like a child safety bottle for your prescriptions. And that's to make sure you don't accidentally knock that wedge and release it, and potentially release the seal when you're putting the dome in place. So simple action, pulling that wedge down, removes it, and then you put the cable retention hardware on, slide it into the closure, and then simply replace the wedge. It simply goes back in the same way that it comes out. And then lastly, you'll see on that wedge, there is a compression screw. So each one of these wedges, again, are completely independent of the other. So what that means is I install 2 cables. Say I do a butt splice day 1. 5 years down the road, I want to come back and I want to install a 3rd cable or a 4th cable. Well, with the wedge technology, I never have to touch those initial cables. So going back to the example of the technician that builds out the closure, does a great job, and then somebody comes down the road and has to add something. Preferably, they never touch that seal again, and you don't have to. So you simply open up the 3rd or the 4th wedge, or the 5th or the 6th, whatever it may be, open it up independently, place the cable in, replace the wedge, and then to ultimately seal it, you'll see there's a black screw on the tip of that wedge. You can utilize your can wrench. So that's a 3/8 inch hex. You take your can wrench, you turn the screw until it stops, and there's a spring-loaded mechanism inside of that wedge that controls the amount of force that you're putting on that gel, and it keeps it completely sealed. So completely independent, don't have to disturb any cables, extends long-term reliability. All right, so as far as splice trays, so with the wrapping tube cable, spiderweb ribbon, another advantage of it is those ribbons separate very easily. So if I utilize a spiderweb ribbon technology inside of a, in a fiber to home network, and I want all the advantages of the mass fusion splicing, but occasionally I need to drop off, 12 fibers or even 1 fiber, say I'm splicing on a drop or I'm splicing on a multi-port terminal or something like that. Then you could potentially have mass fusion and single fusion all occurring in the same closure. Historically, a lot of splice closures require 2 types of trays, a mass fusion tray and a single fusion tray. Oftentimes, the mass fusion tray is deeper because of the rigid matrix ribbon. So what we've done is we've really dialed in what the right amount of height is to still support standard mass fusion, but then give you the added depth that you need to really pack the density inside of each splice tray to get you to some of these higher fiber counts, including the 3456 I mentioned earlier. So what we've done is we've created a universal splice tray. So when you order Apex X2S closure, you get an X2S tray, X2 tray. There's no different depths today. We may look at added depths later, but today there is one depth of splice tray and one type of splice holder. So the splice holder is really my favorite thing about the closure outside of the second to the sealing. That's why I put it in this order. So the universal splice holder, it's an overmolded rubber on top of a hard plastic substrate that snaps mechanically into the tray. So that overmolded rubber is very snug, and it holds both single fusion, that's 40 millimeter, 60 millimeter. And we've even tried some of these really tiny slice holders from Europe. They all hold, and they actually pass the GR 771 drop test. So you can use those and triple stack them per slot, and they don't fall out. In the same slot, you can put mass fusion splices, mechanical splices. You can even put PLC splitters and slide them into the module. So it's truly universal for all the types of fusion splicing that you're doing, or even mechanical splices or splitter devices. So it's one type of tray for multiple applications across the board. Oh, excuse me. Another advantage to the Apex splice closure. So each of those trays, they pivot up. So there's 6 trays in each size, both the X2 and the X2S. They pivot up and lock in place. So and they lock into place automatically. So as soon as you pull it up, it locks into place, and there's a small push trigger on the stem that holds all the splice trays that you push and allows you to rotate the tray down. So it's an automatic locking feature once it's located up in the upper hinging position. Now, another advantage to the Apex splice closure when you're talking about hinging and accessing slack. So once you hinge all these splice trays in the upward position, you have access to the basket underneath. And what we did with Apex is we utilized a molded slack basket. And what we mean by molded is we actually did a plastic basket, which allows you to take full advantage of the full cross-section of the closure. So we've seen closures out there that have a box style or something like that, utilizing maybe utilizing the sheet metal where the box, then it's very squared off, so you have a lot of empty space on the sides of the slack basket. Here we have a molded slack basket that's fully takes advantage of all the cross sections, so it's really large and it allows you to pack a lot more slack into it. Another cool feature that we've implemented is a segmented slack basket. So we had feedback from customers while we were going through and doing some voice of customer work. They really like wrapping tube cable. They said, well, the closure that we're using has one basket, so I have all this almost bare fiber inside of the basket. And what happens when down the road I need to put in a loose tube cable or whatever it may be? I'm worried about those rigid loose tubes pressing, and they kind of want to. And if you've managed loose tube slack and closure before, they kind of want to expand out. They balloon out. They push against the sides of the closure. So what we wanted to do was avoid that. So how do you avoid that? Okay, so that was an interesting question and an interesting challenge to solve. And what we did is we developed a hinging, separate segmented basket that's clear, that attaches separately from the main basket and allows you to place your loose tube slack separately from your ribbon slack underneath. And this is optional. This isn't a mandatory item. But as you can see in the example here, you've got your wrapping tube cable, or it can be standard flat matrix ribbon, slacked at the bottom of the basket. And then above that, you actually, off of the same yoke that attaches all the splice trays, you have a clear separate basket to maintain buffer tube slack. And it's not huge. You're not going to stuff a 288 or 432 into that basket. But for doing drop adds and things like that, you can keep these separate. Another advantage is it being clear. So when I press this back down, as it locks into place in that 45, I can press this back down and lock it into place, and I can make sure when I press this down, I'm not grabbing any fibers, pinching anything or anything like that. Make sure that you're clean down below before you splice closure up and move on to the next one. And it's also hinging to allow you to access the bottom, to access those fibers underneath. I never need to do another add. And we wanted the hinging feature so we could keep all that loose tube slack in place and not have to touch it when we did pull it out of place. So we talked about potentially, a cover that just snapped into place and then you pull the cover off. The issue with just pulling the cover off and discarding it is if there was a bunch of slack there, what do I do with it? So now with hinging, it simply hinges out of place. And all those cables are still tied down and locked into place, just like you see in this animation there. I know this is slick little animation, but in practice with actual cables operates just the same. So a very neat feature that we enjoy about this closure, and really think it ties nicely with the wrapping tube cable, as I mentioned. So that's Apex in a nutshell. Really to expand on AFL and the suite of products that we have, I mentioned that we do have a full suite of products end to end, and we offer these all through KGP. So cabling everywhere from your feeder, distribution, and drop cables. Fiber to the home, so another solution that AFL recommends to the market is our Titan RTD solution. So that's our hardened outdoor multi-port terminal used for fiber to the home as an access point, and that's paired with our Trident hardened drop cables. I mentioned already Splice closures. We also have a variety of wall mount cabinets and wall enclosures that can be placed either indoors or outdoors. I think most folks on this call are probably very familiar with our fusion splicing capability. If you're not, then we have our new fusion splicing, both singles fusion and mass fusion splices available out there in the market, as well as field installable connectors. Whether you want to do a fuse-on field installable connector or a mechanical style field installable connector, both our Fast and our Fuse Connect products are really great products that are a piece of that end-to-end solution. And then when you look at testing, connector inspection, we have a couple products there, the Focus Flex, the Focus Lightning, whether that be single fiber or multi-fiber connector inspection. You clean the fibers and or clean the connectors, I'm sorry, and you want to double check the cleanliness, then we have all those inspection tools as well as the cleaning supplies themselves. So the one-click cleaners, the cleaning wipes, the cleat tops and things like that, we have all those as well. And then lastly, you've got your testing capabilities. So I don't think actually lastly there might be one more, but from a testing perspective, you've got your OTDRs, specifically some of these fiber to home networks that we talked about today, PON OTDRs that can actually test through the splitter and give you kind of a visibility, a view of your entire fiber to the home network all the way through. And then, in addition to OTDRs, really doing the true bidirectional power loss testing end to end. We have our Rogue system with our Arrows cloud-based reporting, as well as some other light source power meter kits for some maybe scaled back technology-wise, but some pretty clear-cut meter readings if you're just doing true power meter type readings. So all in all summary, so AFL, we've got a whole suite of high density cables that can do really, what we're trying to do is these networks grow and grow, reduce congestion in the ducts, reduce congestion up on the poles or on the strand. LM Series is really the leader for the ultra density with a single fiber solution, but maxed at 432 and paired with microducts. So really in tune for jetting capability. And then we have wrapping tube cable spiderweb ribbon. So the ultimate fiber density when you're talking about those super high fiber counts, but it goes all the way down to 144 fiber. So I don't want to scare you with all these really high fiber counts. You do get the advantage of wrapping tube cable all the way down to 144 fibers. And then if you want to get really ambitious, we've got the 6912 fiber as well. Probably not stopping there. You'll probably see some even higher fiber counts, I'm sure, down the road. You never say never. And then you pair that with then the high density splice closures. So AFL Apex, we launched this in December of last year. These were designed with high density cabling in mind, and really focusing on the acceleration of fiber deployments as we enter in and trying to bridge the digital divide. So if you look at cable installation, reducing the learning curve. There's a lot of very seasoned fiber splicers out there that do a great job. And have some of the cleanest looking closures after they're built you'll ever see. But fortunately, there's just not enough of you guys. So, there's a tight labor market right now, bringing in new apprenticeships, whatever it may be. we've got to get them up to speed now in the field as quick as possible because to really meet the needs that are out there. So really fast cable installation for the apex closure, not a ton of screws, and there's no feel to it. It's straightforward and simple, very easy cable installation. High fiber counts in a small space. So we talked about the density that you get, smaller handholds, smaller ducts, more stuff on a pallet, all those things that go coincide with each other. And then all the things with fiber management. So universal splice trays, I don't have to manage a whole bunch of different splice trays. I'm not managing different fiber holders in the same splice tray or splice holders. One splice holder does it all. One splice tray does it all. And then there's some innovative features in there as well for slack management. We talked about the segmented basket. Some things in there to really make fiber management easier for the installers, especially the folks that come in after the fact, to do a drop ad or something like that 5 years down the line. This closure was designed with the future in mind to make sure it wasn't just easy the first time you go into it, it's easy the 10th and 20th time you go into it, because we realized that is the case. So with all that, I could turn it back over to Piper. I know she's been viewing and moderating this session, and see if there's any questions that maybe I can address before we wrap up here.
Yeah, so there is a couple pretty specific questions. So I'll start with this first one here. It says, so if I wanted to ribbonize the LM200 series, could I still mass splice it to a ribbon 250 micron fiber?
Yeah, so there's a couple different features, and I'd encourage you to either talk to your sales rep or check out our fusion splicing section on the website, aflglobal.com. So I don't want to speak out of turn, but we've got a new ribbonizing tool that I believe can ribbonize 200 micron fiber into a 250 micron pitch. I didn't get into the specifics of this, but one thing about our wrapping tube cable, the 200 micron variety, is it does come in, it's a 200 micron fiber, but it's in a 250 micron pitch, meaning the fiber spacing, even though the fibers themselves are smaller, they're spaced out just slightly to where they align perfectly with a conventional 250 micron ribbon. So we do have that capability. But if you had to go to a 200 micron pitch, we do in the newest fusion splicers, there is a removable fiber holder, and there's what's the word I'm looking for? B groove. Sorry. So there's a removable B groove that does have a 200 micron pitch as well. So there is a solution out there for that. The specific how you do it, I can't remember off the top of my head, but there is. I check into some of those ribbonization tools as well as our newest fusion splicer on aflglobal.com.
Great. Okay, and the next question, what is the smallest bolt the Apex splice container will fit in?
So we've done some mock-ups today inside of a 17 by 30 with the Apex X2, and that's with I want to say it was a 432 fiber cable. Now, if you really shrank down the fiber count, now if you went with say an LM series 144, you could probably put that into a 12 by 24. So what you got to do is you got to take into account the length of the closure plus the bend radius of the cable. So you've got your closure in there, and hopefully everybody can see me. I'm waving my hands. So you've got that bend radius that sweeps off the back of that butt entry closure. So that bend radius plus the length of the closure would accommodate a 24-inch long bolt, 12 by 24. You just got to make sure it's married up with the right fiber count. So if you've got any questions on that and you're not sure, we do have a full applications engineering team that we can work with you guys if there's a specific question. 72, 144, 288. What can I do? Let us know. Reach in, and we can marry up that particular application and give you a definite answer, because it does vary so much by fiber count. But if I were to say theoretically a 12 by 24 would work with that Apex X2 up to a certain fiber count with our micro core style cables.
Awesome. Okay, and this is the last question. It says, when talking microduct 13 millimeter ID, are our only options the loose tube micro cables on the LM series, or do you offer ribbon or wrapping tube cable options?
Stay tuned. So today, yes, it's we have a microcore cable that is designed for the 13 millimeter microduct. Obviously, the spider web is a very advantageous technology. We want to leverage that at the same time leveraging it into global technologies. We don't have that technology today, but you know, you never know what the future holds. So yeah, we'll definitely keep AFL in mind if that's a solution you're looking for. But today, to get to those small size microducts, it is a loose tube fiber only.
Perfect. Well, that's a good place to end it. Thank you everyone so much for joining. And Will, AFL, we really appreciate the partnership. It's great. So great presentation. And if anyone thinks of anything else, any other questions, please reach out to me, Piper, or Will, and we will make sure we get those answered for you. But other than that, thank you everyone so much for joining.
Thanks everybody, appreciate it.
Yep, take care. Bye-bye.